Everyone, today we are going to start with the chapter light reflection and rarefaction. In this chapter we have talked about how light shows reflection. So basically we'll be talking about the mirror. Okay, we'll be talking about the mirror. So this chapter we will cover it till the reflection. Rarefaction is not in your first PT, so we'll do it afterwards. First video is still this part. This is very important chapter, very easy chapter though, but important side by side too. So in this chapter, let us start this chapter. Okay, this first part is not important. It talks about how opaque mirror are good for this that though. Okay, let's talk about opaque mirror. First part is not important. Okay, so let's start with the reflection of light. This is important. Here they state about the law of reflection, which you have studied in previous classes, that the angle of incident is always equal to the angle of reflection, and the second law, that the incident ray, the normal and the reflected ray all lies on the same plane. Okay, this is what it talks about. Okay, now this is a activity in physics are not at all important as exam purpose, but if there are some activities that you can do, okay, that you can do with them. Okay, now let's go to plane mirror. Now in this particular part, they are talking about the properties of plane mirror. What is plane mirror, how is it used? So plane mirror, I'll give you the property of plane mirror. Okay, properties of plane mirror. So very big, sorry guys, I'm very confused with my cursor now. Plane mirror. Okay, mirror. Okay, write the spelling on your own. You have to, you are in 10th now, you know. Now plane mirror have many properties. First, the image formed by plane mirror is always virtual and erect. Okay, second property is that the size of the image formed is equal to the size of object. U is donated by object. Okay, then distance of the image behind the mirror is equal to the distance of the object in front of it. Okay, last but not the least, the image formed is laterally inverted. Okay, so these are the properties of plane mirror. Now I would like to draw the plane mirror. It's not appropriate, I have to draw it with this only. Ranges na, let's take a different color. Go. So this is a plane mirror. Okay, this is a plane mirror. This is a plane mirror. This is the center which we always take. So the image in a plane mirror is, how is it formed? Suppose this is a incident ray. This is pole. Center of mirror is known as pole. This is the incident ray. After reflection it will go back here. Okay, then it is something, wait, sorry guys, sorry, it is like, wait, just a second. The image formation which I am teaching you is of plane mirror. How is the image formed by the plane mirror? This image formation you have learned in your smaller classes like 7th and 8th. What were the properties? I have made you all familiar with the properties as well. Now the image formation is like this. It forms a triangle like this. This is the let's say this is a point where the object is place. This is the object, this is the pole. Okay, wait, this is the object, this is the pole of the mirror. Okay, now it will reflect back in this way, forming angle of incident and angle of reflection. This is incident, this is reflection, and this is incident, this is reflection. This is how the image is formed. Then at the back of mirror, they meet at point here, at a point, say here. This is the point where they meet and form an image. This is where the image is formed. So see, every properties has been, the image is virtual and elect. The image formed behind the mirror is virtual, and in front of mirror is real and inverted. This is virtual and elect. Size of the object, see, the size of the object is equal to the size of image. Distance is equal, distance is also equal, and image is literally inverted. Okay, these, it justify all these properties. This is the formation of image by plane mirror. Okay, now this was the only thing talked in this part. See, okay, now let's go to spherical mirror. Spherical mirror have two subdivision. Spherical mirror have two subdivision. First is concave mirror, second is convex mirror. Okay, the concave mirror is this, and convex mirror is this. Now let's go on reading from this part, because this is the what important part you have not familiar with. So the reflecting surface of spherical mirror may be curved inward. Okay, may be curved inward or outward, depending upon what they are. Outward, a spherical mirror whose reflecting surface is curved inward, that is towards the center of curvature, it is called the concave mirror. Okay, this is stated. This spherical mirror whose reflecting, this is the reflecting surface, whose reflecting surface is curved inward. This is inward, outward. Okay, and my writing is very katara, I know. This is in, this is out, short form. Yeah. So this is in and this is out. So these reflecting surface is curved inward. This is called as concave mirror, and convex mirror is totally opposite of what concave is. Now in these whole part till here, what are they gonna talk about? I'll teach you that thing. Okay, wait, I'll teach you what they are gonna teach you all about in these particular area. This is very good. Okay, so this is a concave mirror, this is a concave mirror, this is a convex mirror. That's the concave and convex. Why I'm not able to make a C? Yeah, this is appropriate, the word. So this is a concave mirror. Concave mirror reflecting side is curved inward, whereas convex mirror reflecting side is, this is how convex and concave are represented. So you know this part. Now I'll use different color. This part of the mirror, this part, this size of the mirror, you can say, is called as aperture. Okay, this is the aperture of the mirror. This is the aperture. We call it mirror, but this part is also known as aperture. Okay, it's also known as aperture. It is the size of the mirror only. Okay, then you know the center also, pole. This is the pole. This is pole. The center of aperture or the mirror is known as pole. Then we have center of curvature. Center of curvature. This means, you know, we are doing spherical mirror, so it forms a sphere. I'm sorry for the noise. It forms a sphere like this. So the center of the sphere. So the center of the sphere is known as center of curvature. Here we take imaginary line. Seems to be, such words are used in this part. So the center of the sphere is known as the center of curvature. This, okay. Then we have principal axis. This is the only definition. The center of the sphere is known as center of curvature. Now we have curvature also we have done. No. Why is this? Curvature also we have done. Center curvature, center of curvature. Okay, we have done the center. This done, this done, this done. Now we'll learn about radius of curvature. So the separation between the center of curvature, and the pole is known as the radius. Okay. Now we'll gonna have principal axis. It is a straight line passing through center of curvature, and the pole is known as principal axis. Okay. Then after principal axis we have focus. For focus I need another mirror. So focus P, this is C, this is F. This will be F, okay. So when parallel ray incident on mirror, this is a parallel ray incident on mirror, after reflection they pass or seem to be pass here. They pass or seem to be passed through a single point, that is known as focus. Okay. Now focal length is the separation between the focus and the pole. Okay, the relationship between the focal length is r upon 2 radius of curvature upon 2. This is very important formula, girls. You have to remember this. This is what given in this pura particular part. This is all what is it given. Okay. Now let's go to image formation. See, this is the last part. Now let's go to the image formation by spherical mirror. Again, activity only to read for your preparation. Now in this we will talk about the formation of, where is that part? Yeah, formation of what? Formation of image. This part, girls, this table I'll take up later. Okay, let's go to the representation of image formed by spherical mirror. Now I've told you every single part of the thing. Now in In these image we'll learn everything. So first, there are 4 rules for the image formation by a spherical mirror. So if a ray parallel to the principal axis incident on mirror, after reflection it pass or seem to be passed through focus. Okay, done. This is what it is given in this part. Any a ray parallel to principal axis after reflection will pass through principal focus. In case concave mirror, it appear to diverge from principal focus in case of convex. This is what it is given. I have told you in a simple language. Now the second case here. If a ray passing through focus incident on mirror, after reflection it becomes parallel to principal axis. After reflection it becomes parallel to principal axis. Okay, now if a ray passing through center of curvature or seems to be passing through center of curvature incident on mirror, after reflection it travels the same path. See, you can see it here also. Done. Now this is very important. I've taught you image. Okay, this is an important part. When a ray incident on the point P, after reflection it comes back by incidenting pole in other direction, following the law of reflection. So when a ray incident on pole after reflection, it comes back by incidenting pole in other direction by following the law of reflection. This is what it is given in this whole part. Done. See how we are covering parts and covering the chapter. Now the image formation by spherical mirror can be justified. We are very close to the end of the chapter. Let's see. 18 minutes. Okay. Recording 30 minutes. Okay. Now in this part we'll see the image formation of concave mirror. Okay, image formation by concave mirror. I want you all to make notes till my next slide. If an object is placed beyond C, this is at infinity. Beyond C wala, where is it? Here it is. If the object is placed beyond C, the image formed I'll make it and then explain you. These are very complicated diagrams. Concave mirror. When only 3 main points are important for you, F and this is C. Okay, when an object is placed beyond C, the image formed will be between C and F. So nature will be always real and inverted till I not say ruko. The nature will be real and inverted. Okay, so here the nature will be real and inverted. When the object was placed beyond C, when the object is When the object is placed beyond C, the image formed will be between C and F, and the size of the image will be point size, or let's say smaller than the size of the object. When the image P, F and C, when the object is placed at C, the image formed will be at C only, and the size will be same, real and inverted, till I not say ruko. Second case, if the, why is it not zooming? I've zoomed a lot now. Zoomed a lot. Zoom now, zoom. Yeah, nice. Now we are going row wise. Okay, we are going row wise. If the object is placed between C and F, between C and F, the image form will be beyond C. Image formed beyond C, real and inverted till I not say ruko. Image formed beyond C, sides will be enlarged in this case. In these cases, it was same as the center of curvature. It was point size in this, point size in this, same in this. Here it is enlarged. Now okay, now if the object is placed, last was C and F, now it will be at F. This is very interesting case. The image formed will be at infinity, highly enlarged. Okay, and the nature will be real and inverted till I not say ruko. Now I am saying the golden word ruko, because now the image formation will be what? Guess what? Virtual and erect. This is how. So this oh shit, my god, what the hell happened now? This is I've completed now. How did it vanish suddenly? Now the image formation is real. Now the image form will be virtual and erect, and the size will enlarge. Now the size will enlarge, and if the, this is the last case, I don't know, I'm not finding space, I'm doing it here only. Now if the object is placed at infinity, the image form will be at focus, size will be very small or point size. Chalo, done. Image is done. Uses of concave mirror. A concave mirror is commonly used in torches, searchlights and vehicle headlight to get a powerful parallel beam of light. They are often used as shaving mirror, makeup mirror to see a larger image of the face. Dentist uses concave mirror. One case, second case, third case, ऐसे आ रहे हैं ना, so much overlapping things. Third case, dentist uses concave mirror to get a larger image of teeth. This, so you can, if you have common sense, you can guess now. Last is very important goals. Large concave mirror are used to concentrate sunlight to produce heat in solar furnace. Important. Large concave mirror are used to concentrate sunlight to produce heat in solar furnace. Now formation of convex mirror, very close to the end, very close to the end. Okay, very close to the end. Now convex I have to make, but only two cases, so nice space, lots of space, bigger mirror I'll create. So sorry. Nice mirror is becoming now. Pole. Now this time where will be placing focus? Very good, behind mirror here. F. This is center of curvature. So when the object, now I'll do, when the object is placed at infinity, so the image formed will be where? Object placed at infinity, the image formed will be at F. मेरा अभी हो नहीं रहा है because I'm not using scale, but it will, this is what the case is. Image formed will be at F. Do it from both sides, it looks beautiful. Beautifulness is very important, na? Very important. Image formed will be at F. And very important thing, image formed in convex mirror will always have a diminish and small size. It will be one another thing, it will be virtual and erect also always. Then the, and see कितना अच्छा है, हाँ, concave mirror से तो very better. There is so much to remember in concave. It's better to be simple than to be complex in some things, na? Now the second. Why I'm making concave? There were so many that now concave is on my hand, on my tip on finger. So when the object is placed between infinity and pole, guess where will the image form? How can you guess, girls? You're studying it for the first time, no? Understand. This is how it will go now, guys. Wait guys, wait. This is how it will go. This all you have to learn, I'm just explaining. Okay, so the image formed will be between, not coming in between. This is wrong, you might be drawing it like this. It's better that I do it correctly now. Okay, wait. Here is the object placed. This is the focus को थोड़ा और दूर करो ना मैम, otherwise go on ना. This be very important thing, तो I forgot it. So now when the object is placed between infinity and pole, the image formed will be, this will go like this. Image formed will be between, very good girls, between P and F. 3 golden rule I told you. What will be the nature? Always what? Virtual and erect. Always virtual and erect. Size diminished. Some have highly diminished. That focus have highly diminished size. This is still better. And the third golden point, remember what was it? I too forgot my thing. Diminish, smaller in size. Okay, yeah. Done. Tick. Done. See this now. When the image is placed at infinity, the position of the image will be at focus behind the mirror, highly diminished, virtual and erect. Between infinity and pole, the image form will be between P and F and diminished and virtual and erect. See, nice. Last topic of the theory, uses of convex mirror. Convex mirror usually used in vehicle. Convex mirror are used as, very important girls, very important. Convex mirror are commonly used as rear view mirror in vehicles. The mirror are fitted on the sides of the vehicle, enabling the driver to see the traffic behind him slash her. Slash her को correct करो because her never drives correctly, na? Never sees the mirror. To facilitate what? Safe driving, which is not possible in the case of her. So convex mirror are preferred because they always give an erect image. Through though diminished image, also they have a wider field of view as they are curved through outward. Thus convex mirror are used. Driver to view much larger area that wouldn't be possible in plane mirror. Okay, now these are some questions given for the homework. I want you all to do this. From here we come to an end. These are girls, these are numericals which has to be done in a different section class. Different, only 10 minutes it will take to explain you how was how did I explain this part. Please let me know. Please let me know. I've made many efforts. Many efforts. See, that's why I did not rub. अच्छा चलो bye.